When I am doing web development, I've always stayed away from using your typical and standard framework, like React, Vue, or Angular. Or there are moments where I don't even use a framework at all. But when I have to use one, Svelte has always been my go-to since the beginning. Its simplistic nature and approach to things makes me love it, like how it is compiled, and especially how it is doing its reactivity without shipping a full runtime like the other frameworks. So today, we will finally see what is going on under the hood. Svelte, as you probably already know, is a compiler. It turns a Svelte code, which consists of the script, the template, and finally, the CSS style into a plain JavaScript that our HTML can just use and inject. The Svelte compiler does three things: parsing, static analysis, then code generation. These steps are what Svelte does to compile your Svelte code into a valid, fast, and efficient JavaScript output. The very first step Svelte takes is parsing. Parsing means taking a piece of input and turning it into something structured and meaningful. Say you have this piece of code right here. The parser will read through it and break it down into its fundamental parts. Then transform it into something called an abstract syntax tree, or AST for short. An AST is essentially a structured, tree-like representation of your code that captures its meaning in a way that's much easier for tools and compilers to work with, instead of dealing with raw text. So back in our Svelte code, the Svelte compiler will split it into three parts: the script, the template, and the style. The Svelte compiler will then parse these parts and give us an AST that looks like this. This AST will contain our JavaScript, the template, and the CSS. The next step the Svelte compiler takes is static analysis. Static analysis is essentially the process of looking at our code without actually running it, and figuring out what depends on what. The purpose of this is to figure out what variables we have defined, mutations or updates that are in our code, and the variables and functions we used in the template. After the Svelte compiler parses our code from the previous step, it runs an analysis by traversing the AST using an algorithm called depth-first search. This algorithm explores a branch of the tree as deeply as possible before backtracking, then continues exploring other branches until it traverses all of the nodes. In this analysis, Svelte will take note of variable declarations, update expressions, or any expressions that indicate an update or mutation, and finally, any variable expression in the template. After this analysis is done, Svelte has now built up a map of relationships between the script and the template. The very last step Svelte does is code generation. This is where Svelte finally generates the JavaScript code. This step needs two things: the AST and the static analysis result from the previous steps. With these, Svelte will traverse the AST again, but this time, each node corresponds to a JavaScript instruction. Let's take a look on how it creates the template first. Say you have an H1 element. Svelte will look at it and will generate a JavaScript instruction that looks like this. It will define a variable for that element, create that element using the createElement function from the document, and finally set its text content. Svelte will do this for all of the nodes in the template. But what about the variable expression nodes, where it depends on variables from our script? All this logic will actually be wrapped inside a createFragment function. This function will accept a context argument, and this context is an array that contains all of our variables and functions we defined on our script. This function is also responsible for managing the DOM lifecycle. It provides a create function, where our elements will be created, mount, where our element's going to be inserted in the DOM, and things like event listeners gets added. Update, where update to the elements happens by checking which variable changed based on the argument passed. This part is very simplified on what Svelte does. Svelte actually does some bit magic optimization to check which variable changed. But for the sake of simplicity, this is essentially what Svelte does. And finally, the destroy function, where things gets detached and cleaned. Now let's go over into how our script gets generated. Svelte will traverse the script's AST again, and it will track all of the variables and functions we defined. If it encounters an update expression, it will transform it into this invalidate function. This is Svelte's internal function, and does that bit optimization I said earlier. But it essentially triggers the update cycle from our fragment to get run. After all this, it's now going to convert this AST into a raw JavaScript code and wrap it inside this instance function, where the invalidate function is also going to get passed. And by the end, Svelte will use this tracked variables and return it as an array. This instance function is going to be the context that gets passed into the fragment earlier. And lastly, Svelte will create a class that is going to connect these two functions and handle the componentization and the update cycle for our fragment. This explanation covered only the core ideas and basic functionality of Svelte. The framework goes much deeper than what we've discussed here, but I hope this gives you a solid starting point to understand how Svelte works under the hood. As much as I would like to go deeper than this, time wouldn't really allow me to. So if you want to support me and help me create more of these videos, I've opened up a Patreon with the perks like your name featuring at all future videos. The source code for this very video you are watching right now, scripts, and a source code for a working basic Svelte compiler. You'll find the link down in the description. And that's all for this video. Thank you for watching, and I'll see you next time.